Okay, here we are for some sequences and series. It's been a while. So they say that these are arithmetic series, which means there's constant addition going on. If you look at 29 as an example, you see we're just adding 9, adding 9, adding 9. And so what the evaluating the series means is that we're trying to add up the first 8 numbers. So all of these plus 9 would be 66, 75, 84, 3. We want to add up all 4 of those numbers. Now you can break out the calculator and you can do that, but there's a formula for it. And number 30, there's 14 numbers, so it's just a really big pain to try to do a high number, to add up a large number of numbers in a series. And it's a lot easier if you know the formula. So the formula says that the sum of n numbers in an arithmetic series is n over 2 times the first term plus the nth term, whatever the last one they ask you for is. And we know there's an explicit formula that can tell us any term. It's just nd plus a0. So in this case, the 14th term is 14 times the common difference. So what's the difference between these terms? Again, we're adding 9. 9 goes there. And what is term 0? It's the term that would have come before 16, also known as 7. So I can find out pretty quickly what the 14th term is. And this just becomes more and more efficient as we do more and more numbers. So 133 would be the 14th term. So if I want to add up all 14 of the first 14 terms, I just do 14 divided by 2 times the first term plus the 14th term. I don't plug in 14 anywhere except over here for the n values so that I can find out what term 14 would be in that list. So we do 133 plus 16 times 14 over 2, also known as 7, and this is 1043. So if this was like find the sum of the first 200 terms, if we try to do that on a calculator, it would take forever and be miserable. Now it may be miserable, but it doesn't take forever, and that's the key. Number 31 is a good example of one that would be really painful to do without knowing the formula. To ask us to add up the first 50 terms starting at term 1. So what is this thing right here? This is just the explicit formula. The explicit formula can tell you any term. So if I want to find term 1, that would just be 9 times 1 minus 2, which is 7. If I want to find the 50th term, that's just 9 times 50 minus 2, which is 448. So if I want to find the sum of the first 50 terms, all I have to do is 50 over 2 times 7 plus 448. That's 11,375. And if you're using your calculator to try to do that, you'll still be doing it. These kind of questions, if it's on a final, if it's on the ACT, anything that's timed, then something that I'll hear a lot as a math teacher or see someone say about the ACT is that, like I just ran out of time. Well, this is not meant to be done by adding up on your calculator and going 7 plus, let's see, plus 9, that would be 16, plus 7, that would be 23, plus 30. Like that takes a long time. That shows that you don't really know how to do it. There's a mathematical way to do it. This is the formula for it. And you have to know what all of this means. That's what they're testing, not can you type in 50 numbers in your calculator and hit enter. Anywho, Number 33, we got to figure out whether this is arithmetic or geometric. Find a term named and the explicit formula. Well, how can we tell? Well, this is a whole bunch of pluses and this is a whole bunch of timeses, multiplying. So what are we doing here? How are we getting from term to term? Looks like we're adding 2 to me. Okay, so what does that mean? This means this is arithmetic. So how can we find the 25th term? We need the explicit formula. Any term is just equal to the common difference times the term number plus term 0. What's term 0? Whatever comes before this. Subtract 2 from -1, you get -3. So 2n minus 3 is any term. So let's check that real quick. We know that the fourth term should be 5, right? So term 4 should be 2 times 4 minus 3. 8 minus 3 is 5. Cool. Our formula works. Now let's use it to find the 25th term. 2 times 25 minus 3. 47. Boom. (34) says that we should find the common ratio. Term named in the problem, explicit formula, recursive formula. It's a lot of formulas. We can do it though. So how are we getting from term to term? Let's say that you didn't know. Okay, we're assuming that we're taking -16 and we're multiplying it by something and we get -64. How do we solve for that question mark? Just take -64 and divide it by -16. When you do that, you'll see that 4 is that common ratio. Just keep multiplying by it over and over again. So let's define the recursive formula. Recursive just means, how do you define a term by the term in front of it? Any term is just a ratio times the term in front of it. So for this one, any term is -4 times the term that came before it. That's the recursive formula. The explicit formula, much more useful, says that any term is equal to term 0 times the ratio to the n power to the term number. Well, what's term 0? What would come before -4? Let's divide by -4 and find out. It would be 1. The ratio is negative. Nope, it's +4. Oh, it's -1. Sorry, -1 because it's 4. The 0 term is -1, -4 divided by 4. The ratio is 4 to the nth power, any term. I really recommend checking this. We know that the fourth term should be -256. So if our equation works, we should be able to plug in 4 right there, and it should give us -256, and it does. So I feel good about it. That allows me to go ahead and do the 9th term. 262144. That is a big number, isn't it? And I don't know about you, but I'm getting tired of sequences in series. So I'm going to jump down to 39, where something a little more exciting happens. And then we'll do 39 and 40. It says, create an explicit formula for this sequence and find the term named in the problem. Well, there's a problem. They just tell us the 20th term and the 34th term. So that's kind of difficult. How do we do that? Okay, so let's imagine that, okay, we got 410 is the 20th term. If I wanted to get to the 22nd term, I would have to add the common difference 2 times, right? To get from 20 to 22. So how many differences do I have to do to get to the 34th term? 14, right? Term 34 is term 20 plus 14 differences. So 690 is 410 plus 14 differences. Subtract 410 from both sides and you get 280 equals 14 differences. So the difference between term 20 and term 34 is 280. And we did 14 differences to get there. So we have to take that 280, divide by 14, and you get that the common difference is 20. All right, so there's a couple ways you can do this. It wants an explicit formula, so we could go all the way back to term 0 if we wanted to. And how many differences? So like if we are at term 20, that would be term 0 plus how many differences? 20 of them, right? So term 20 is 410. 410 is term 0 plus 400. Term 0 is 10. And so now we can write our explicit formula. Any term is just 10 plus 20 times the term number. And again, I would recommend, I'm losing it. Again, I would recommend trying my formula out. So 34, the 34th term is supposed to be 690, right? So let's try it. Da, 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 da. So our formula does work. And we can use it to find the 27th term, 10 plus 20 times 27. So that would be 550. Let's do the same thing over here. We've got term 2 is -8. Term 3 is -16. How did one get from that to that? They tell us it's geometric, so we're multiplying by something. Looks like we're multiplying by 2. So if I want to write the explicit formula, I could back up and I could divide by 2. That would give me -4. That would be the first term. And the 0th term would be -2. So any term is the 0th term times the ratio to the term number. 0th term is -2. The ratio is 2 to the 8. So we just plug in a 12 right there. -2 times 2 to the 12. 192. D. Have a good day. All right, there we have it. All the way through number 40. Did some matrices, did some sequences, and we will jump into all of this soon, very soon.